Hey guys, how you doing? Today I want to solve with you a pretty interesting limits problem in which, well, it might be a bit trickier than you might think. So let's do it. So this is the problem I am talking about. Now, the first thing you might do is, well, of course, you simply substitute -1, you're gonna get a denominator of 0. But one thing you might think that you can do is, well, maybe here we can group some terms and then factor them, and maybe we can get x plus 1 and maybe cancel out something. Well, I'm going to show you. Let's try that. So we're going to say that this is going to be equal to, now what can we group here? In this case, we could place these two x's together, and then these 4 and these 6, and factor out 2 from them. So we could have in this case x times, we would have x times, x times x squared plus 1 plus, should we take -2 out or +2? Well, I'm going to take +2 plus 2 times -2x squared plus 3. And all of this is going to be divided by x plus 1. Now, in this case, a pretty simple form, or something you might be able to see, is that this is very similar to this that we have down here, okay? And also something we have is that we cannot group actually these two terms because they're not the same. Remember that in this case, if they were the same, you could put them together in a parenthesis, but we cannot do that. Now, what I'm trying to show you is that no matter how you try to group all the terms, you're not going to be able to find a point in which you have factored out a lot of terms and you can cancel out x plus 1. One thing you can do is actually, well, we know this function is just simply a quotient, okay? At the end of the day, pretty much all fractions, you can represent them in a quotient, okay? So what I am proposing is that we solve this fraction right there, okay? We're not gonna factor, we're not gonna substitute. That is what you would normally do in a limit problem, but in this case, we're not gonna do it. We're gonna solve this fraction. So we're gonna say this is equal to, first of all, one thing we should do is try the polynomial remainder theorem and see if this equation is in fact this fraction is exact. So that means that it has a remainder of 0. So I'm gonna try that. Now we know in this case this would be simply x minus -1. So in this case you would get the +1. Now we're gonna try the polynomial remainder theorem. So that theorem states that you're gonna have -1 cubed minus 4 times -1 squared plus -1 plus 6. And now if this is equal to 0, that means that this division is exact. So let's try it. And in this case we would get -1. In this case we have +1 minus 4 minus 1. I'm gonna write the entire thing again, plus 6. Now this is gonna be minus 6 plus 6. We know this is gonna be equal to 0. This implies that this division is exact. Okay? So that means that we can find a quotient out of all of that. Okay? Now let's do that. What should we use? Well, we could use synthetic division and play with the coefficients. So yeah, let's do that over here. So we know in this case there is a coefficient of 1. We know there is -4. We know there is +1 and 6. And we're going to be playing with, in this case, -1. Okay? Now let's see. So we've got this. We know we lower down this 1. We get -1 when we multiply these two. Then you add, so you get -5. -5 times this is going to give you +5. This is going to be 6. And 6 times this is indeed -6, which means 0. Remember that if you're dividing by a linear term, your last number that you get in synthetic division, if you say 0, it means that the division is exact, which is what we proved with the polynomial remainder theorem. So now, in this case, we can use these coefficients to find the quotient. So what can we do in this case? Well, we know that the greatest degree that we have in this expression is 3. And the quotient has to be a degree less than the numerator. So we know this would be x squared. 1, the coefficient, and 3 minus 2 minus 1, I'm sorry, that's going to be x squared. X squared minus 5x and plus 6. Now if this is true, we should multiply this by this and get back our previous equation. Now let me do that real quick. We should have this times x squared minus 5x plus 6. Let's see if this is true. We got x cubed minus 5x squared minus 5x squared. Then we get plus 6x. And now we have plus x squared. And then minus, yeah, you can see now you're gonna get minus 5x, and then you're gonna get plus x, and in this case, plus x squared minus 5x squared, you're gonna get minus 4x squared, okay? So I'm not going to complete it just for the sake of time, but you see it is true, okay? This quotient is indeed correct. So now, we know we're taking the limit as x is approaching minus 1, okay? So now this is gonna be a parabola, and now we just need to find, well, what is the value that we are getting closer and closer to in our output when our input is getting closer and closer to -1. So now that's what we're gonna do. We're gonna substitute. So this is gonna be equal to the limit as x approaches -1 in the function. This is equal. Well, actually, no, this would not be equal, but you know, it keeps going down here. So we have minus 5x plus 6, and now we just substitute. This would be equal to minus 1 squared, that is 1, minus 5 times -1 plus 6. And now how much is this? It's gonna be plus 5, 1 plus 5 plus 6. This is gonna be 12, okay? So you should have gotten this answer if this limit, if you completed or evaluated this limit correctly. So I hope you guys enjoyed this video. I think this video just shows that do not rely on mechanic methods to find limits. If you cannot substitute, don't just straight away go to factoring, okay? It is the most common method, but sometimes it will not work, okay? And you have to do synthetic division. So I hope you guys enjoyed this video, and see you in the following one.